All right. So you might be wondering, why? Why are we graphing? Today we're going to be graphing, but why the unit circle? All right, so there's a right triangle that spins around the circle. Like, what's the point of me caring about this, right? So as we kind of look here, we see that we have sine on the y coordinate, cosine on the other, right? So this is cosine, right? Let me see if I can move this. I'll just move myself over here. We have cosine over here, and then we have sine over here. Now, we already talked about this at length, and so you've gotten accustomed to, hopefully secant, cosecant, cotangent, tangent, that's fine. But sine and cosine are kind of the goal for today, and we're going to graph those. And so what we're saying is the x coordinate now for our graph is going to be as we spin around, this is our x coordinate, as our values go from 0 all the way to pi to 2 pi, okay? As we go around, that's our x coordinate on our graph. Our y coordinate here will be our y coordinate on our graph, okay? And conversely, we're going to then go around the unit circle, and then we're going to graph cosine, all right? So it all involves this unit circle. So let's actually now go to this. This is where hopefully you guys printed this out, and you're going to follow along. It's very useful to kind of get your hands on this. All right, you don't want to just watch this. You really do want to graph this. Now what I'm gonna do is I'm going to while I'm graphing this, I'm also looking at the unit circle. Okay. Hopefully you've memorized some of these. Now these are major points on the circle, right? You have 0 degrees, pi over 2, which is 90 degrees. This is pi. That's 180 degrees. This is 270 degrees. This is 360 degrees. So this is all in radians, and we're going to keep it in radians pretty much for the rest of our trigonometric unit, okay? So let's look and see what's actually going on. If I were to look at the y coordinate at 0, okay, when x is 0, or that is the angle is 0, then the y coordinate is actually 0 as well. All right. Now let me just kind of stress that right there. Okay. At 0 degrees, the y coordinate is 0. Okay. All right. So at pi over 2, the y coordinate is actually pi over 2. Pi over 2, it's actually here at 90 degrees, and the y coordinate is 1. All right. So we're going to put 1. What happens at pi? I'll do it one more time. At pi, the y coordinate actually is 0. Okay, so we're going to keep, we're going to keep that going. We're going to find that's -1. And then as we get to 2 pi, it's back to 0 again. So we have some points here. This is a function. So I'm going to go 0. Well, first of all, let's go from 0 to 2 pi. The middle of this is pi. All right. The middle of that is pi over 2. The middle of this is 3 pi over 2. Because remember, this is 4 pi over 2. 4 pi over 2 is just 2 pi. And the highest value we're going to get as we go around the unit circle, the tallest it ever gets is 1. The lowest it ever gets is -1. All right? So when it's 0, it's 0. When it's pi over 2, it is 1. When it is just pi, it's 0. When it's 3 pi over 2, it is -1. And when it's 2 pi, it's 0. Now what happens is if we were to actually get into the details here, what'll happen is we've got ourselves a beautiful little wave here, okay, that goes on forever. And this actually goes in this direction too. So if this was -pi over 2, this guy would go like that. Now this is amazing, right? This is actually a wave. All right. Now let me just kind of show you give you a video here of like what full screen. Now what'll happen is that that's to like some cool beat as well. So watch what happens as we spin around the circle here. But what happens is y coordinate moves, we've got a wave. Now you wouldn't think that triangle and another create this full oscillating curve. Exactly what happens. Exactly. Okay. Now, what is this useful for? Well, what it's used for is lots of things. Like, it is electricity, it is sound, it is incredible. Let's just focus on sound first of all, okay? Now, we're going to get into what frequency is based on a sine wave, all right? But I'm going to go ahead and push. You're not going to hear anything for a while. The thing is, this actually represents the cycles that this sine wave is going to do in a second. So right now, you can't hear anything. I'm going to turn this up as loud as possible. In fact, I'm going to point the mic. I'm going to point the mic. Okay, ready? Just I'm pointing the mic at the speaker here. You can't hear anything because right now this is like, it's not dog whistle. This is actually the other end of the spectrum. You can't hear anything until you get about 200. And this is how many sine waves are actually flowing through to your ear. Now I can hear this. I don't know if you can. But all sound is sine wave. And it's the frequency of this wave that creates the pitch of the sound. Not the volume, but the pitch. All right. Now, at this point, as you get about 1,000 hertz, dogs are going to go crazy. Okay. I possibly could go crazy. I'm ready to smash this computer, but to get to about 2,000 things. Okay, not 2,000, maybe 3,000. My dogs, I can hear him barking. But it gets to a point where you won't be able to hear it. It'll kind of just give you a headache. So now we're getting into inaudible sound here. But these are all sine waves here. All of them. Okay. And they're compressed. And that's what we're going to investigate. And I'm going to stop. Yeah. That's absolutely enough. So moving back to this then, why... That's an ant. Get out of here. So this simple sine wave occur, like we're talking about rotation around a unit circle, is the fundamentals of sound. Okay, here, electricity. Okay, this is electricity book that I've been reading, and this is about the AC current that's in your house. Okay, so AC current is just a single phase electrical current that pulses back and forth into your house and out of your house, right? It's not like a battery, right? We have these power stations that create that pulse that, creates a backward and forward motion of electricity to create, power in our house. And so I was looking at this and I was just thinking like, yeah, I mean, it's just electrical current pulses like this. And what happens is you get into more industrial, where you need a lot of energy through those outlets, you're going to want a three-phase, which is much more efficient, where you have three sine waves happening simultaneously through those outlets. So it's extremely important to understand just the nature of a sine wave, okay? And so I'm going to stop right there, and I'm going to post another video that is related more to your homework next. But, just investigate sine waves, Google it, think of frequency, or even words like amplitude and period. All right, changing those. It's kind of interesting to investigate.